Hey guys, this week the video's on solving single variable problems. I'm pretty sure you guys have done very similar questions before, right? But I just want to go over it again because very soon we're going to be talking about linear equations. And in order to understand linear equations, it's really important that you understand how to solve a single variable problem. So this will be available on the content tab under week 10, and you'll find the video there as well, right? Now, to solve single variable equations, right? To solve these equations, we must combine like terms first, and then we isolate the variable by undoing the order of operations, right? Remember the order of operations was PEMDAS, right? So we go backwards, and isolate again means to get rid of everything but that variable that we want, right? Some equations only take one step to undo, while others are multi-step. For example, the first one, t over 3 equals 7. How would we calculate that? So let's go on our notebook. T, oh, let me get t divided by 3 equals 7. So our point of interest is this t. We want t. So in order to get t by itself, we have to get rid of this over 3, this divided by 3 on the bottom. So we have to do the opposite operation. To get rid of the 3, get rid of the divided by 3, we do times 3. So that gets rid of this. We're left with t is equal to 7 times 3. Remember, if you do it on one side, you have to do it to the other side as well. 7 times 3 gives us 21. So that would be our answer, right? So we're going to go over a couple more examples, right, on the notebook. This is not definitely from the PDF, but I want you guys getting a better understanding. Now, instead of t divided by 3, what if it was t times 3? So this is another example. What if it was 3t equals 12, right? And we want to get t by itself. Again, this, when number is written next to a variable, that means multiplication. So we got the opposite of multiplication, which is division. And if we do it to one side, we have to do it to the other side. This will get rid of the 3's, and you're just left with t is equal to 12 divided by 3 gives us 4. Again, let's try another one. T plus, since we're sticking with the 3, let's just continue. T plus 3 equals 9. How do we get rid of the plus 3? We do minus 3. Both sides gets rid of the 3. T is equal to 6. And finally, minus, right? So we did divide by 3, we did times 3, we did plus 3, and we're going to do minus 3 equals, let's say, 10, right? This is minus 3, so we're going to do the opposite. Plus 3 on both sides. We get t is equal to 13, right? When we did plus 3, this gets rid of it, right? Now, I don't want you getting confused, right? Up until now, we had t in the front and the numbers in the back, right? What if we had something written like this? 3 plus t equals, let's say, 15, right? We still want to get rid of this 3. We want to isolate or have this t by itself, right? We want to get rid of this 3. So this is a positive 3. There's no negative sign in front of it. So this is a positive 3. So we got to do minus 3 on both sides. This gets rid of this 3. T is equal to 12. That's how you find it, right? So don't get confused if the t is on the left side or right side, right? Especially when it's an addition problem, right? If it's something like a one step, you just get rid of the number and you get the variable by itself. So back to our PDF. So what if it's two steps, right? So we have 4x minus 5 equals 11, right? In this case, we want to solve for x, right? The variable here is x. So let's go back to our workbook. 4x minus 5 equals 11, right? This is what we want. We want the x, right? But we have to get rid of everything that's furthest away from it, right? We can't do divide by 4 yet, right? Just like our previous one right here with the 3t, to get t by itself, we have to do divide by 3. But in this case, this is not just 4t, we have a minus 5 over here, right? So we have to get rid of the minus 5 first, so to get rid of everything furthest away from the variable, right? Plus 5 on both sides, that's how you get rid of the 5. We get 4x equals 11 plus 5, 16. We want we want x by itself, so we do divide by 4. That's how you get rid of the times 4 by dividing it to the opposite. X is equal to 4, right? 16 divided by 4 is 4, right? Now, if we had 4x minus 5 equals 11, right? If we did divide by 4, right? Divide by 4. You can't just take one portion. When you divide by 4, you have to divide this entire thing by 4, right? The entire side, right? If I divide this entire side by 4, I would be left with this fraction. I can't separate this 5 out, right? I can't separate this 5 out. This becomes 11 over 4, but this entire fraction has to be divided by 4, right? So that's why it's important to first get rid of this 5 and then plus 5. Let me erase this. Plus 5, and then you could divide by 4 on both sides, right? Because whenever you're dividing or multiplying, you have to do it to the entire side, right? You can't just choose only this side and do the divide 4. You can't forget about the minus 5. So we're going to be doing the first couple of pages together as practice, and then there's a lot of questions in the last couple of pages that I want you guys to do right on your own. I'll give out the solutions um, by the end of the week, right, or early next week. I'll give out the solutions so you could check, right? So let's work on these questions right here. All right. So these next three problems, the first one is single step. The rest are the second one's also single step. Third one has some like terms, right? So let's work on the first one. So we got negative 5v equals 75, right? Here we want to solve for v, so we have to get rid of this negative 5, right? Not just the 5, but the negative sign that comes along with it, right? So this is being multiplied. We want to do the opposite. Divide by negative 5, divide by negative 5. This cancels out. We just get v equals 75 divided by negative 5 gives us negative 15. Next one. 2 plus b equals negative 2. Again, this is very similar to the one we had before with the t and the 3. We want b by itself. This is a positive 2 because there's no sign in front of it, right? So we want to get rid of that. We do minus 2 on both sides. We get b by itself equals minus 2. Negative 2 minus 2 gives us negative 4, right? Last one, excuse me. Last one, we have 9x minus 10 minus 3x equals 2, right? So this is the first time we're introducing like terms, right? Before we start minusing or moving around numbers, right? Minusing or subtracting or dividing, right? We want to look for like terms, right? Up until now, the variable only appeared once, right? But now the variable appears 2 times, right? On one side, especially. So we could combine like terms. We have 9x and we have minus 3x, so they combine to give us 6x, right? 9 minus 3 gives us 6. Nothing changes with this 10, so we just leave it as a minus 10. Nothing changes with this 2, so we leave it as a 2. So now here's our simplified equation, right? It's the same thing, but we just combine like terms. Now, you need to remember, do we get rid of the 6 first or the 10, right? Remember, in this case, we look for what's furthest away from the x, right? Furthest away from the x is the 10, so we want to get rid of the 10 by adding 10 on both sides, right? Let's make some space. We add 10 on both sides. We get 6x equals 12 plus 10. 2 plus 10 gives us 12. And then we want to get rid of the 6, so divide 6 on both sides. We get x is equal to 2, right? I just moved it from down here to up here, right? So we have a little more space, right? Remember, if I did from up after solving combining like terms, if I did divide it by 6 instead of the plus 10, I would have had to divide 6 this entire. So let me use a different color ink, right? Let's say I didn't do the plus 10. If I did divide it by 6, I would have had to divide 6 the entire side, right? Let's say I didn't do that. I would have to divide, and this wouldn't have solved anything, right? This wouldn't have gotten rid of the 10, this wouldn't have gotten rid of the 6, right? It would have just made it a little bit more complicated, right? So that's why you want to get rid of the 10 first, right? Get rid of the 10 and then get rid of the 6, right? So let's go on to the next questions. Now these three, they look like there are a lot of steps. In some sense, there are a couple more steps than the ones we've been doing so far, but the idea is exactly the same. First one, right? We have minus 2, so negative 2 plus 10p is equal to 8p minus 1, right? First thing we want to do is move around. Whenever you have these type of questions, we want to move all the variables to one side and all the regular numbers to the other side, right? And we want to move the smaller one, not the bigger one, right? So we have p on left side and we have p on the right side. We have 10p and 8p, right? We want to move the variables to, remember, to one side. So we look at what's bigger, 10p or 8p, right? Obviously 10p is bigger, so we move the smaller one. So to move 8p to the left hand side, we do minus 8 on both sides. This gets rid of the p, right? And we get we're gonna get a simplified equation at the bottom, right? But if I'm moving the variables to the left, I gotta move the regular numbers to the right. So minus 2, how do you get rid of it? You do plus 2 on both sides, right? So this is what I'm doing. I'm doing two things in one step, right? I'm moving the variables to the left and I'm moving the regular numbers to the right, right? And look at what happens. So this minus 2 plus 2 cancels out. 8p minus 8p cancels out. 10p minus 8p gives us 2p is equal to minus 1 plus 2 gives us positive 1, right? Let's move this over here. 2p equals 1. To get p by itself, you divide it by 2 on both sides. We get p is half, right? Or if you did on the calculator, you got 0.5, same thing, right? So if you want to do this in 2 steps, that's perfectly fine. So I'm going to do it here really quickly. Minus 2 plus 10p equals 8p minus 1. Again, so the first step is moving the variables to one side, and you want to move the smaller count, not the bigger count. This gets rid of the 8p. You get minus 2 plus 2p is equal to minus 1, right? Plus 2 on both sides because you're trying to get p by itself, right? Plus 2 on both sides. This gets rid of the plus 2. 2p is equal to minus 1 plus 2 gives us positive 1 divided by 2 divided by 2 gives us p is equal to half, exactly the same as this one, right? So you could either do it in this kind of way where you do them all in one step. That way you know you're moving the variables to one side and the numbers to the other side, or you could do it in a little bit longer way, right? Whichever works for you, you could do it. Now, all of these questions, right? Remember, you're solving for a variable, right? All of these questions, you could always check by plugging it into the original, right? So I'm going to erase this, right? You could always plug it into the original, see if it holds, right? If the original question holds, right? So we know that p is equal to half, right? Or 0.5, right? So let's plug that in over here, right? Just to check. So 10 times p is half, is equal to 8 times p, right? And p is half minus 1. Let's see if this makes sense. 10 times half is 5, so half of 10 is 5. All right, minus 2 plus 5 is equal to half of 8 is, so 8 times half is 4 minus 1. So let's put this in the calculator. Minus 2 plus 3, minus 2 plus 5 gives us 3. 4 minus 1 is also 3. So that means we did it correctly. P is equal to half, right? That's a way you could check, right? So this is your check process. Next, let's go into our next question, question 2. Now, the first step you should do whenever you see parentheses, right, is to distribute, right? So let me erase this right here, make some space. First thing, again, is always distribute, right? So this 4 gets distributed to the 2r, and it gets distributed to the 8. This 1/7 gets distributed to the 49r and to the 70, right? So let's work this out. 4 times 2r gives us 8r. 4 times negative 8 gives us negative 32 is equal to 1/7 times 49 is equal to 7r, right? In the calculator, you could just put that in. 1/7 times 49, you get 7, right? That's how I did it. 1/7 times 70, yep, gives us 10. Right? Again, same way, right? Whenever you have a fraction times a whole number, is basically that whole number divided by the denominator, right? So for example, 1/7 times 70 is the same thing as 70 divided by 7, which is 10, right? So let's move on. Right now, this equation now looks very similar to the one on top, right? We have the variables on both sides and we have numbers on both sides, right? And remember, you got bring all the variables to one side and all the numbers to the other side. That's the trick. And you move the smaller variable, right? The smaller counter variable. So you have 8r and you have 7r. So what's smaller? Obviously the 7. So I'm going to move the 7 minus 7r on both sides, right? And if I moved all the variables to the left, that means I have to move all the numbers to the right, right? So I have to get rid of this minus 32. The way I get rid of it, I do plus 32 on both sides, right? So let's see what we get rid of. We get rid of the 32 on the left, and we get rid of the 7r on the right. So now we have a simplified equation. 8r minus 7r gives us just r. 10 plus 32 gives us equal sign 42, right? All this long equation got solved in kind of a couple of steps, right? We don't have to do any dividing because we got r by itself. So we just know r is equal to 42. Again, you could plug this in, right, to the original equation and work it out. You'll see it's going to give you they're going to equal each other on the left and right hand side. All right, so let's move on to the third one. So we have 2m plus 5 equals 5 times m minus 7, and then the whole thing to minus 2m again, right? So we can't, before combining like terms, remember always distribute whenever you see parentheses, right? So this 5 gets distributed to the m and to the negative 7. So we write this out again. 2m plus 5 equals to 5 times m gives us 5m. 5 times 7 gives us minus 35 minus 2m, right? So let's start combining some terms, right? We're going to leave the left hand the way it is for now, right? Because we see 2m's on the right hand side. 5m minus 2m gives us 3m, right? 5 minus 2 is 3 minus 35. Now we start moving over the variables, right? So we have 2m and we have 3m. The smaller of the two is the 2. So we move the 2m. And since we move the variables to the right, we move the m this direction, we want to move the 35 the opposite direction. We want to move the 35 to the left. So we do plus 35 plus 35. We get rid of the 2m. We get rid of the 35. We're left with 5 plus 35 is 40 equals 3 minus 2 is 1, so just m. M is equal to 40, right? And if you wanted to plug that in to your original just to see if it works, right? So I'll do that really quickly. So we got 2 times m is 40, plus 5 equals 5 times, again, m is 40, 40 minus 7 minus 2 times 40. Let's see, this is going to be 80 plus 5, so this is going to give us 85. So this side is supposed to give 85 as well. So 5 times 40 times 40 minus 7 is 33, minus 2 times 40 is 80. Let's see what this equals. 5 times 33 is 165. 65 minus 80 gives us 85, right? So 85 equals 85, so that means we're doing it correctly. Next thing I want to talk about is inequalities, right? They're very similar to solving for equality, which is using the equal sign, um, but they have some special rules, especially when it comes to dividing and multiplying negative numbers. So we'll get to that. So here you have an inequality, right? 2 is less than 4, right? That's a symbol of inequality, right? What happens to you add 3 on both sides, right? 2 plus 3 is 5, 4 plus 3 is 7, 5 is still less than 7, right? The inequality holds, right? If you if any number is added to each side of a true inequality, the resulting inequality is also true, right? And let's do some examples of that before we um, get into the longer ones. Again, I'm sure you guys have seen inequalities before. This let's go over the symbols, right? This is less than, right? That's what this is. This symbol is greater than. This one, less than with the line on the bottom, is less than or equal to, and the greater than and the line on the bottom is greater than or equal to, right? So I'll leave that there for now, right? Make sure you guys copy it. So the example we went over was 2 is less than 4, right? Now inequalities is if you add a number to both sides, right? 2 plus 3 is 5, 4 plus 3 is 7, right? The symbol stays the same, right? So 5 is still less than 7, right? What if we had, now another example, 10 is greater than 2, right? Now what if we multiply both sides by 5, right? 50 is still greater than 10, right? So the, if you multiply by a positive number, the inequality symbol stays true as well, right? It stays, you don't change it, right? Same thing with subtraction, right? If I did subtracting, so this case right here, if I did minus 1, right? 2 minus 1 is 1, 4 minus 1 is 3, 1 is still less than 3, right? And if I did division, idea is the same as long as it's with a positive number, right? So 10 divided by 2, 2 divided by 2. Remember, if you do it on one side, you have to do the same thing on the other side, right? 10 divided by 2 is 5, 2 divided by 2 is 1, 5 is still greater than 1, right? So that's how we know that if you do any operations, right, involving positive involving multiplying or dividing positive numbers, right? The symbol stays the same, and if you do any operations like adding or subtracting, again the symbols stay the same; they don't change. All right. The first example we go over is x minus 45 is less than or equal to 13. We want to solve for x, right? Again, very similar to the equalities, right? If you want x by itself, right, you have to get rid of everything on that side. So here, x not being multiplied by anything, so we want to just get rid of this 45. Since this is minus 45, we want to do the opposite, plus 45 on both sides. We get x is equal to 13, not equal to, see, symbol. X is less than or equal to 13 plus 45 is 58. Now, I want to teach you guys how to graph an inequality, right? Graphing an inequality is basically using a number line and understanding which part your variable will be shaded in on that number line, right? And that number line, the numbers you put on it depends on the final number you're left with, right? So we write a number line, we draw a number line, and we have 58 in the middle, right? So 57, 56, 59, 60, right? So put some numbers around it. Now, the circle is going to be on the 58, right? Because that's our main number that we're looking at, right? Now, there's two types of circles. There's shaded in circles and there's hollow circles, right? Now, let's go back to our definition. Whenever you're talking about less than or greater than, it's always an open circle, right? Whenever you're talking about less than or equal to, or greater than or equal to, it's always a closed circle, right? This means it could be that number or less than, or it could be that number or greater than. And the open circle means it can't be that number, but it could be everything less than that number, or the greater than one. It can't be that number, but it could be everything greater than that number. So in this case, right, we're looking at x is less than or equal to 58. So we shade in, right? Again, equal to means shading in, right? Less than means all the numbers that are less than. So 56, 57, 55 going on. So we shade in this side. So the graph would look like that. Okay. Now, um, next example goes over this similar idea. 5p plus 7 is greater than 6p, right? In this case, we have variables on both sides, but we only have one set of number, right? But it works out for us, so let me make some space. It works out for us because we want to move the smaller of the two variables, right? The smaller count. So 5p is on this side, so we get rid of 5p, move it over here. It's gone. 7 is greater than 6 minus 5p is just p. 7 is greater than p. Now, if we want to graph this, we start with that number of our interest, so 7, right? Let's put some numbers around it, 8, 9. Let's put some numbers under it, right? 5, 6, 7, 8, 9, right? 2 or 3 numbers are good enough on both sides, right? Now, is it going to be an open circle or closed circle, right? Again, this is just greater than, right? So it's going to be open circle. It's not greater than or equal to. Now we look at P. 7 is greater than P, right? So that means P has to be everything less than 7, right? Since 7 is bigger than P, right? So that means we have to shade in everything again to the left hand side. P is 7 is greater than P. That means P has to be everything less than 7, right? Think of it that way, right? Another way you could think of it is by plugging in numbers, right? So let's say you plug in P is equal to 8, right? So using this example, 7 is greater than, if P is equal to 8, right? We don't know that, right? What if P is equal to 8? Does this hold? Is 7 greater than 8? No, right? But what if, so this is not right. So what if P is equal to 5, right? Is 7 greater than 5? Yes, that means we know that P is everything on the left hand side, right? That's one way you could think about doing this. So let's go over a couple more examples, right? So this one is 22 is greater than m minus 8, and the next one is d minus 14 is greater than or equal to negative 19. All right, so the first one, 22, is greater than m minus 8. We want m by itself, so we want to get rid of this minus 8. So we do plus 8 on both sides. All right, this gets rid of the minus 8. We get m on the right-hand side. We get 22 plus 8 gives us 30. Since we didn't, we know that adding a number doesn't change the symbol, so we leave it the way it is, right? 30 is greater than m. So we want to graph this. Again, the center number is the one that we just calculated. Couple of numbers below it, 29, 28. Couple of numbers above it, 30, 32, right? Put a circle, right? Open circle because this is just greater than. And again, 30 is greater than m, right? That means m has to be everything less than 30, right? So again, we could use that example. What if is m equal to 32, right? Let's check. Does that make sense? Is 30 greater than 32? No, right? So that means m can't be on the right-hand side. M has to be on the left-hand side, right? If it was 28, is 30 greater than 28, right? If m was 28, yes, that makes sense. That means it has to be on this hand side, right? Now let's go over the next one. D minus 14 is greater than or equal to 19, right? We want to get rid of this minus 14, so we add 14 on both sides. D is greater than or equal to, again, make sure to use the calculators, right? If you have trouble with adding along with a negative number, negative 19 plus 14 gives us negative 5, right? So D is greater than or equal to negative 5. So let's draw out our number line. Negative 5 in the middle. Let's put in a couple of numbers, right? Again, this is on the negative side, right? So over here you get negative 4, negative 3, and on the right you get negative 7, negative 6, negative 7, right? Remember this way, right? On the right hand side the numbers are increasing, and on the left hand side numbers are decreasing, right? Negative numbers, the smaller the negative number, the greater its value, right? So negative 4 is bigger than negative 5. Negative 3 is greater than negative 5, right? Negative 7 is smaller than negative 5, right? I want you guys to understand that the value of a negative number makes it smaller, right? Depending on how big that value is, right? I want you guys to understand that, right? Think of it like you owe people money, right? If you owe somebody $7, that's more than owing somebody $3, right? As opposed to if you owe somebody $3, right, you owe them less than owing them $5, so you have more money left over, right? You have more money for yourself. That's why negative 3 is greater than negative 5. So open circle or closed circle, again, this is greater than or equal to, so closed circle, right? D is greater than, so it has to be all the numbers bigger than 5, so all the numbers bigger than 5 is on the right hand side, right? So right hand side means bigger numbers, right? If you're having trouble with this negative, right, try to remember, right? If I extended this all the way down, right, it's going to be negative 2, negative 1, 0, 1, 2, 3, right? You see how the numbers are increasing to the right, right? The numbers are increasing to the right. That's how you put it in the negative sign, right? It's always increasing to the right and decreasing to the left. 5, 4, 3, 2, 1, negative, and then 0, 1, 2, 3, 4, 5, right? D is greater than that. So D could be any of these numbers. D could be any of these numbers that's greater than negative 5 and equal to, so it could also be negative 5 as well, right? I want you guys to understand that. So the last thing I want to talk to you guys about is what if we multiply both sides by a negative number, right? Multiply or divide by a negative number, what would that happen? And also moving around um, using fractions. So we had established, right? So 10 is less than, let's say, 50. right? If we multiply both sides, right, so that's the dot, means multiplication. If we multiply both sides by 2, right, we will get 20 is less than 100, right? That still holds. But what if we did a negative number, right? What if we did 10 is greater than negative 4, right? 10 is greater than negative 4. We could establish that, right? Now, what if we multiplied it by a negative number now, right? Negative 2. So 10 times negative 2 gives us negative 20. Negative 4 times negative 2 gives us positive 8, right? Is negative 2 greater than 8? No, it's not. It's less than 8, right? So whenever you multiply by a negative number, right, you have to flip the signs, right? So flip the inequality symbol when multiplying by negative number, right? When multiplying by a negative number, you flip the inequality, right? Now, again, I'll give you another example of this. So let me erase this, right? So 2 is less than 6, right? 2 is less than 6. If I multiply this by negative 3, multiply this by negative 3, you get negative 6, negative 18. Again, negative 6 is not less than negative 18. Negative 6 is greater than negative 18, right? And the same thing holds for if you have less than or equal to, greater than or equal to, right? Again, initially 2 was less than 6, but negative 6 is greater than negative 18, right? Now, same thing holds if you're doing division, right? Let's say you have 100 is less than 200, right? 100 is less than 200, but if we divide it by negative 2, divided by negative 2, right? Again, we're dividing it by a negative number. 100 divided by negative 2 is negative 50. 200 divided by negative 2 is negative 100, right? Negative 50 is greater than negative 100, right? Negative 50 is bigger than negative 100, right? So we flip the signs, right? So flip the inequality symbol when multiplying or dividing, right? Or dividing by a negative number, right? So dividing or multiplying by a negative number, you flip, make some space, multiplying or dividing by a negative number, you flip the sign. Also, I want to show you guys a trick on getting rid of fractions, right? So let's say you had 2 over 3x is equal to 12, right? Is equal to 12. You want to get x by itself, right? Now, this is a fraction, so you want to get rid of this entire fraction, right? You want to get x by itself, right? So to get rid of this entire 2 over 3, we want to multiply it by its flipped. So multiply it by 3 over 2. What this does is you have a 3 on the top, you have a 3 on the bottom, cancels out. You have a 2 on the top, a 2 on the bottom, cancels out. You're left with just x. Again, same thing, multiply by 3 over 2 on this side, because remember, you're multiplying it on both sides by the same number, right? So we get x is equal to 12 times 3 over 2. Again, if you're doing this on calculator, remember, whenever you have a whole number times a fraction, this whole number is basically over 1, right? 12 times 3, 36, divided by 2 gives us 18. So x is equal to 18. Again, if you want to check it, you want to plug that in. 2 over 3 times 18. Let's see if it equals 12. 18 times 2, 36. 36 divided by 3 gives us 12. Works out. Same thing if this was an inequality, right? So I'm going to erase this. Delete. right? Same thing if it was an inequality. Let's say we had 4/5 x is greater than 10, not 10, let's do 12, right? 4/5 x is greater than 12. We want to get rid of the 4/5, so we want to multiply it by its flipped, right? So multiply by 5/4 on both sides, gets rid of the 5, gets rid of the 4. We get x by itself is greater than 12 times 5, 60, divided by 4 is 15. We get 15. Again, I don't expect you guys to do this on your head. In your head, use your calculators to do this, right? So 12 times 5 over 4 gives you 15. So you could do it this way, 60, right? And you have over 4, 15. That's how I got this right here, right? If I wanted to graph that, this would be 15 in the middle, 14, 13, 16, 17. Open circle because there's no less than sign. There's no equal to sign. X is greater than. That means x has to be everything bigger than 15. Right? Now that you have that knowledge, I want you guys to complete the rest of the worksheet. Right? So starting from right here, -2/5 p is less than -14. Right? Going down to the end of the page, end of the worksheet. Right? So all these questions, right? You don't have to if you feel comfortable in understanding all this, you don't have to do every single one if you don't have the time. But I'd highly recommend you do as many as you can. The more practice you get, the better it is for the quiz, right? Our next quiz, quiz 4, is going to be on um, solving single variable inequalities and equalities, right? Single variable equations. So I highly recommend you guys do all this. I'll put up a solution again, probably beginning of next week. So whichever the ones that say graph, right? It's usually the ones with the inequalities. Graph those. That way you get practice with the graphs as well, and continue working on them, right? This is for practice for you guys, right? This is, you will not be handing this in, but this is practice. So as you get better in this, the quiz is going to be easier and the assignment is going to be easier as well. That's going to come up. I'm going to send out an email about those, but in the meantime, I'm going to post week 10 discussions, work on that, right? If you have any questions in the meantime, send me an email. All right, guys, take care.